As every portrait painter knows, the slightest change in the shape of eyebrows, the curvature of lips, or a crease in the forehead can alter the expression of a person's face and affect how someone else responds. Yale University neuroscientist Joy Hirsch says scientists would like to understand the neurocircuitry behind this interaction between individuals.
The visual information and facial expressions are actually coded intimately with the systems of the brain that are coding the language processes. And this is something that hadn't been really appreciated before.
Hirsch and her colleagues at the Yale Brain Function Lab are looking into what actually happens in our brains when we engage in simple conversation. Wearing skull caps with sensors that can register brain activity, researchers Shaul Yahiel and Shaw Brunner explain to each other pictures of simple objects.
The new information here is that visual reports of, say, facial information are an intimate part of the language system as it is being used in an interactive situation like a dialogue.
Facing each other, then again separated by a partition, they describe simple pictures appearing on computer screens, such as a basket, a bowl of rice, or a lighted cigarette. A small laser in each of the 64 access points in the skull caps shines a bright light beam that penetrates about 2.5 centimeters into their brains. The reflected light changes depending on whether the blood vessels at that point are oxygenated or depleted of oxygen, showing the level of brain activity. A near-infrared spectroscopy machine records and displays the patterns of information flow.
We want to take the physiologic information we recorded on the NIRS machine in the other room, and we want to know where is that information anatomically.
In similar research, scientists at Princeton University are scanning the brains of people as they tell real-life stories and then playing back those stories to others.
What we are asking is whether the listener's brain becomes similar to the speaker brain during natural real-life communication.
Scientists say the findings may eventually help them better understand the patterns of neurocircuitry involved in communication and how they are different in people suffering from disorders such as autism or depression. George Putic, VOA News, Washington.